Hello everyone, in this video we're gonna solve this particular problem. The problem statement says the U-tube in the figure has a 1 centimeter inner diameter and contains mercury as shown. If 20, this is volume, of water is poured into the right hand leg, what will be the free surface height in each leg be after the solution has died out? So drawing a figure of what we have in here. So we have a manometer that has 2 legs, and we have mercury in it. So let's imagine the situation in here. So this is mercury, and we have for sure pressure acting on the 2 legs, and in the figure they told us this distance from here to here, it's 10 centimeter, and distance the same thing, and here the same thing. Ready. So they're asked if we add water on this side, right side. This is my right, and this is the left. So we're talking about this side. So if we add water, if we put water in here, okay, what will be like the change in height? Like what will happen in here and what will happen in here? So let's see. If we redraw this again, we would have a change as illustrated in here. Let's see. Make it bigger. Michael drawing. So this is like that, and this is like this, and this is like that, and here this is the mercury that we had, and this is the water that we added, and this is the water that we added in the manometer. So we have mercury, and we have H2O, okay? So previously, if you look at it, we had 10 centimeters in this side, and 10 centimeters in this side, and 10 centimeters in this side. If we add water on this side, they're gonna push down the mercury, and the mercury on this side will go up because we're adding another liquid in here. So that displacement we can represent it by delta H, and now we don't know how much is delta H. We don't know the height, so we're gonna find out. And then this distance, if you remember, recall this is 10, and now it's shorter, so it's gonna be 10 minus something. We don't know how much it decreases, right? So it's gonna be 10 minus x. And this distance was 10, but it's increased. So we don't know by how much. So what we're gonna do is it's 10 plus x, the unknown that we're gonna find. So decreases, increases. Like increases, decreases. Oh no, it's backward. Sorry. This is decreases, increases, right? So what we can do in this situation is first apply the principle of communicating vessels. right? Draw a line where it's desired. So we draw a line where we can find the unknowns. I would draw a line right here, and I'll call this line X. Alrighty. So we know by this principle, the pressure at Bx would equal to the pressure at Bx bar. Alright. So let's see what is Px. Px is the atmospheric pressure in here. Forget to draw this. So we got pressure plus the density. What we have in here is mercury. So density of mercury, gravity, and then the delta Z, which is our Z. It's going this direction. This is my reference point. So this is Z, and Z in this situation is equal to 10 plus X. So 10 plus X. Okay, and this is equal to the pressure at the other point in here. So in this point, what is the pressure? As always, pressure plus the density of water. We have water in here. And then the gravity. And what is the delta Z for water? It's just delta H. That we can call it anything. You want to call it whatever. I just called it delta H. Right? And then plus the density of the other liquid that we have. So we have liquid in here and liquid in here. So we have mercury in here, right? Yeah. So the density of mercury divided by gravity divided by the delta Z of the mercury, which is 10 minus X. So we have this equation now. We can cancel like terms, right? Do the algebra. This was cancelled, and 10 from here and 10 from that side. So we're gonna end up with rho mercury Gx equal to rho and then from here, from this equation, we will be solving for X. Let's see. And do the algebra. I'll show the steps for the sake of argument. At G X plus and then you get the X's on the side. You get the density of G. Alrighty. And then this is equal to density of water. G delta is the same thing. Alright. And then X. This is 2 rho G. And this is G, gravity. This is equal to rho H2. Water, G delta H. As we can see, we can cancel the G from both sides. And then, sorry for scrolling down and up. And then, we get the X to Z. this is equal for sure, as we see, delta H, and then solve for X. This is rho H2O over 2 rho G delta H. Ready? So we know the density of water and we know the density of mercury. It should be given. Once you get this question, it should give you the density of water and density of mercury. Or you're looking at tabulated tables or whatever reference you have while you're taking your exam. So, water no delta H. This is the argument in here. So here's the deal. We know volume is equal to area times height. And then from here, we know volume should equal to, what is the area? It's 4 pi divided by 4 d squared multiplied by h. So, what is delta h in this scenario? It's gonna be equal volume divided by pi over 4 d squared. So, we found an equation for delta h that we can substitute to find the value for it. We're given the volume in the question statement. It said, it told us we have 20 water. So, the volume of water is 20. Divided by the area, which is 1 over 4. And I believe they told us 1 centimeters inner diameter. So we're gonna substitute the 1 and centimeters. So this is gonna be centimeters cubed. So cancel out. So we have 2546 centimeters as an answer for delta H. And then we go back to our equation here, the X, and we substitute the delta H value in the equation that we had. So X equal 25.46 divided by 2,000 kilograms per meter cubed. 0.00 kilograms per meter cubed. And this is, in fact, the density of mercury. You should be given this. And this is the density of water. And this should equal to 0.49 centimeters. So, did we answer the question? No. So, in the right leg, what is the change in height? This is what the question asked. We didn't answer the question yet. So we said in the right leg, we had an increase in the level of the fluid. So that was a 10 plus x, right? So in this situation, we found x to be 0.49. And here is 10 plus x. This is going to equal 10 plus what we found at the 0.49, assuming this is right. And you get the answer. So the left leg, on the other hand, it's 10 minus x. No, I have it flipped, I think. Isn't it? Yeah. Here's 10 minus x and 10 plus x. This is my right and this is my left. So you figured it out. So this is 10.49. Just ignore these terms and you will get the point. This is the right, the 10 minus x. 10 minus x, yeah. So I have it flipped. So this right and this is left. So this is the answer. This is how much change we have in the heights. And this is what the question was asking about. Thank you for watching and see you in the next video.